Hello, and welcome to the follow-up session on NGSS and 3D learning. Last spring, we began our conversation about the importance of integrating DCIs, cross-cutting concepts, and SEPs as we are planning our lesson or units. If those words do not sound familiar, do not worry. I will review them with you. So, what will we accomplish today? We will review the 3 dimensions of learning and performance expectations. We will go onto the NGSS website and learn some points of navigation, and we will go through an example of how to form a 3D organizer. And the goal is to end up with you creating your own 3D organizer, which I hope you will use as you are planning your next unit or lesson. When you're thinking of 3D learning, you can think of a cake. The content, or DCI, is the actual cake. It is the eggs, the sugar, the flour, and other ingredients that you may need. The SEPs, or science and engineering practices, are the baking tools. They can be a spoon, a measuring cup, a baking sheet, or even your hands. The cross-cutting concepts, or CCC, are the frosting that keeps the cake together. So, what you end up with at the end, or your end product, is the performance expectation. In this example, the performance expectation is baking the multi-layer cake and covering it in frosting. The goal is to have your students use DCIs, CCCs, and SEPs completely intertwined at all times while working on a phenomenon. In previous years, educators practiced separation, where they teach the content one day and ask the students to practice it the next day. We all have done it. We would teach the content, and then for the next week, we would ask the students to work on labs or worksheets or simulations or videos, and then we would give them a test. The goal now is to not separate the content from practices. In a well-designed 3D learning unit, the content is covered naturally as it comes up and as it is needed. So your performance expectations are the accessible statements of what students should know and be able to do. Your performance expectations are not instructional strategies and are not objectives. This is one of the most common misconceptions. They are intended to describe the end goal. But keep in mind, like with our example with the cake, the performance expectations that are proposed by the state may not be the ones that the teacher wishes to use. So in the example from before, the state suggested that we build a multi-layer cake, but the teacher may decide that cupcakes or muffins are a more appropriate assessment of the content and the skills that the students learned. There's absolutely nothing wrong with changing the assessment. However, your students should be able to know what the big ideas are, and they still should be able to meet the performance expectations proposed by the state. Next, let's take a look at the actual website and let's figure out how to navigate it and look at the 3D learning parts of it. So if we click on the link right here, the Next Gen Science Standards will come up and we're going to focus on the high school link. If we scroll down, we can use this drop-down menu. If you are physics, here are your links that you will follow. If you are life sciences, these are the ones that I will follow. And for earth science, you're going to be clicking on the ESS. So for life sciences, if I click from molecules to organisms, structure and processes, it will take me to a new screen. As you can see, here are my performance expectations. Next, what we're going to do is we're going to look at the 3D learning. If you click on practices and core ideas right here on your right, you can see that your performance expectations change color. What you see in blue, construction and explanation, developing or using a model, planning and conducting an investigation, these are your science and engineering practices or the skills that your students should be able to master. If we are looking at the text in orange, these are your DCIs or the content that you are focusing on. So for example, for LS1-1, the structure of DNA determines the structure of proteins. Right? If we keep going, we can look at feedback mechanisms and homeostasis. We still have our mitosis and differentiation. So all of the content is still there, but now it is mixed in with particular skills that we want our students to focus on. Next, if we click on practices and cross-cutting concepts, again, you can see that the skills or the practices are in red, so we still have our constructor explanations and models. And then the cross-cutting concepts are in green. So in here, you see the structure of proteins. You can see interacting systems. We can see illustrating. We're looking at words like homeostasis and transfer of energy. So in here, these are the ideas that we will see multiple times through the year, just within different contexts. So as we go back to our PowerPoint, this was our first example. Again, in blue are the science and engineering practices or the skills, and in orange is the content. As you can see, this full performance expectation, the two are intertwined. Again, if we look at the practices and the cross-cutting concepts, we can see in blue are skills that we should be learning, and in green are the cross-cutting concepts or the theme that runs through the year. Another thing that I'd like for you to take a look at is assessment boundaries. So if we go back to our website and we scroll down, you can see this orange box, and these are your DCIs. If I click on structure and function, it will take me to another screen. And what I would like for you to do is to scroll down, and as you are scrolling, this will give you the endpoint bands depending on what grade that you teach. So by the end of 2nd grade, by the end of 5th grade, by the end of 8th grade, let's take a look at this. If you take a couple of minutes and read this paragraph, you can see what students content-wise are expected to know. One of the content points that jumps out at me is that students are expected to know that the cell membrane forms the boundary that controls what enters and leaves the cell. In here, students are not expected to know how transport works. So when I take over teaching biology in high school, I can see that by the end of 12th grade, we are focusing on feedback mechanisms, positive and negative, and what is going on inside the living system. So when my students come in, I'm going to quickly review the cell membrane, but I'm going to focus more on homeostasis and the actual transport through the membrane. You can do this for any one of the standards. We can keep scrolling. We can click on growth and development. And again, for any of these, if we keep scrolling, we can see what the assessment boundary would be. I keep on using the word phenomena, but let's make sure that we are all on the same page about what this means. So, what do we mean when we say that students are engaging in a phenomena? Is it A, having kids learn about a scientific problem and how it was solved? B, having a fantastic hook at the beginning of a lesson, which we never revisit again? Or C, answering a "huh" question that ties individual lessons into a unit? If you answered C, you are correct. So now let's go back to focusing on our 3D learning. This is the organizer that you are going to use, and hopefully this will help you when you're planning your lessons and units in the future. As you can see, we have our triangle with our DCIs, our SCPs, and our CCCs with the phenomena in the middle. Where you start is completely up to you. What I did was I started with DCIs and then connected it to a phenomena. So if I start with the DCIs, I can see that there is structure and function and growth and development. Those are the two DCIs that I will be focused on. Now remember, DCIs is your content. Now we need to pick a phenomena that would make sense with these DCIs and also would engage your students. So the phenomena in this example that I chose is, how do we grow? Now, if we have our DCIs and our phenomena, we can start thinking about some SCPs that we would use. If you can see in the blue bubble, there is a list of 4. You do not have to use all 4 for a lesson. You certainly are more likely to use them in a unit. So during this unit, I'm going to focus on modeling. I will start with having my students develop an initial model based on their preconceived ideas about how do we grow. Everybody has ideas, so putting together an initial model should be relatively easy for them. Next, I will have my students work with evidence that I provide, or I could have them design their own investigation. Either way, at the end, they will have a number of different evidence that they can use to either revise their initial models or come up with a completely new final model. And the goal at the end will be to use this evidence and argue as to why this model is the most correct one and the most up-to-date one that they have. Now, I will focus on the CCCs and tie everything together. Again, here's a short list. You will not use all of them in each of your units. In this case, cause and effect seems like the most appropriate one. So what I would do here is I would focus on how do we grow and then bring in a twist. What would be the problem if the right hormone or the right signaling molecule were not activated? How would that either increase the growth rate, or how would it maybe prevent the cells from growing or an organism from growing? So all of this helps to answer the question of how do we grow, and as you can see, we used all three parts of our 3D learning model, and we tied them all together into answering the question of how do we grow. So what I'd like for you to do right now is, if you are working in a group setting, get into a small group, use the triangle that we provided in the handout, and put together your own organizer, which hopefully you will use later on in the year. If you are by yourself, do the same thing. Go to the website, follow the steps, pick a DCI, pick a phenomena, and then figure out which SEPs and CCCs would go with your phenomena. So again, here's the steps. You would go to the nextgensciencestandards.org. You will search the standards. You will pick your DCI. Make sure you pick high school, and then you will start building your organizer. Now, if you're working in a small group setting, what you can do is you can share out. Once you're done with your organizer, let everybody know what your phenomena was, and then what the 3 dimensions of learning that you are able to cover. What are some CCCs? What are some SEPs? And then what question are they helping your students answer? If you're working alone, you can certainly find other people to talk to. And once everybody is done, thank you so much for listening. If you have any questions, please feel free to email me. Here is my email address. It is ekaterina.salufo@edison.k12.nj.us. Good luck.